Welcome back, students. In second lecture, we have stopped on this question number 7. So we will continue from here. So in this third lecture, we will see few examples on compound interest and the next topic, which is effective rate of interest and nominal rate of interest. So let's go back and begin from question number 7. So we were reading this question in second lecture. A person borrows 6,000 rupees for 3.5 years at 7.5% per annum compound interest. How much does he repays? So here's the solution. Principal amount borrowed is 6,000. Number of years is 3 by 3.5, which is a mixed fraction. Simplify this to 7 by 2. So multiply this 2 with 3 and add 1 in the multiplied. So 3 into 2 is 6 plus 1 is 7, 7 by 2. The rate of interest is also a mixed fraction. Simplify it to 15 by 2. So 15 by 2%. So R is 15 by 2. So the amount he needs to pay back to the bank or some person from where he had borrowed is calculated by this formula. Amount principal is equal to principal in bracket 1 plus r upon 100 raised to n. So put all the values at their places and solve it. So 6,000 and this bracket 1 plus 15 upon 2 into 100 is 1.075 raised to 7 by 2. So there's a problem how to calculate this fractional power. So this half in this 2 in denominator, I can take it as square root of 1.075 and power 7 is there in the power. So take square root. We can find square root easily on our non-scientific calculators. So it comes 1.0368 raised to 7. So do all the calculation. This much amount he needs to pay back. So let's take 8th question. It says that the difference between simple interest and compound interest on some money for 2 years is rupees 15. Okay. So rupees 15 is the difference between simple interest and compound interest for 2 years. If the simple interest on the same sum for 4 years is 1200 rupees for 4 years, find the sum and the rate of interest. So we have to find two things, P and R%. So let's read the solution. Let the sum invested be rupees P at the rate of interest R% per annum. These two are unknown things. And the question says that the simple interest on that principal sum P for 4 years at the same rate R% per annum is 1200 rupees. So from the formula of simple interest, SI is equal to P into R into N upon 100. I got 1200 What is 4? This is number of years, and this r is unknown. So we got this. So I've separated P and R from this LHS and removed everything in the LHS. So this is what we get. This 100 is multiplied here. This 4 goes into the denominator. It gives me PR is equal to 30,000. It also says that P in terms of rate. P is 30,000 upon R. We will use this equation star. I have named it equation star. Also given that the difference between compound interest and simple interest. We know that compound interest is greater than the simple interest. That's why I have taken CI first, is 15 rupees. So from the formula of compound interest, which is amount minus principal, the amount formula is this. This whole thing is the amount, and this is P. So this in red color thing is compound interest, minus this green thing is simple interest, is 15 rupees. Next step. So what is P? Instead of P, I am writing this equation star. P is 30,000 upon R. So what I'm doing, I am converting this equation in language of R. So instead of this P, I have written 30,000 upon R, and in the bracket is as it is, raised to 2 minus P. This P I have written is 30,000 upon R in this step, in next step. Minus 2PR upon 100 is equal to 15. So in this equation, P is gone. So I have replaced P by 30,000 upon R. So here is P, this one is P, and 2PR. What is PR? Go back to the PR is 30,000. So I've replaced PR by 30,000, and 2 upon 100 is equal to 15. So now this equation is in R. Simplify this. So what are the simplification? So this square will make this 100 as 10,000. So I've written 10,000. So this 10,000 cancels with 30,000. 3 is left here. And what else we can cancel is 100, and this is, so this becomes 2 into 300, so 600. So this is what we get after simplification. 3 upon R, 100 plus R square minus. So this 3,000, I have written 3 into 10,000. Sorry, 30,000. 3 into 10,000 upon R is equal to, and this minus 600 is going to that side to add with 15, which gives 615. Now, so I have taken LCM on this side, which is R. This is the LCM. And this 3, which is here and here also, I have taken it common 3, and then it shifted into the denominator in RHS. So then simplify this 10,000 cancels. We have only R square upon plus 200R, and 3 divided by 615 is 205, and this R gets multiplied here. So this is 205R. So we have this quadratic equation in which constant term is absent, which is very easy to solve. So I've taken r common, which says that either r is equal to 0, rate of interest is 0, which is not possible, or r minus 5 is equal to 0. That is possible thing. So r is equal to 5, so rate of interest is 5%. Now from that equation star, this is the equation star, you just put r is equal to 5, you will get principal amount 6,000. Now we have some questions on depreciation topic. What do we mean by depreciation? If we have some machinery with some I have bought that machinery for p rupees, and with time the money, the value of this machine will get depreciated with time. So that come in this topic, depreciation topic. So let's read this note. If p is the amount or present value and r percent is the rate by which present value decreases every year, then the value of depreciated value of p, then the value or depreciated value of p after n years is given by this formula. If you look at this formula, this will be similar to the amount in compound interest. So we have difference at this point. So there is a negative sign. Instead of plus, we have negative sign because it's going to decrease by r% every year. We have one more note. If p is the present amount and r1% is the depreciation rate for first year and r2 is the rate of depreciation for second year, similarly rn is the depreciation rate for last nth year, then the depreciated value after nth year is given by this. So this p, and I have that bracket multiplied those many times. So 1 minus r1 upon 100, r2 upon 100. So we have those many brackets as the number of rates or the number of years. And they are multiplying individually because all the rates of depreciations are different. So here we have a question on depreciation. A machine depreciated 10% per annum for the first 2 years, then 7% per annum for the next 3 years, depreciation being calculated on the diminishing value. So the final amount will be the principal amount every year. So it's going to decrease every year. If the value of the machine is 10,000 in the beginning, then find the average rate of depreciation and the depreciated value of the machine at the end of 5th year. So this is the timeline. So in the beginning, initially I have bought that machine for 10,000 rupees. First year, second year, third, fourth and fifth year. So for first 2 years, the value of machine is depreciating by 10%. Then the remaining 3%, it reduces at the rate of 7%. Now using the above formula, the depreciated value after 5 years. So we have 5 different rates. So I have 5 different brackets to multiply. And this is how it looks. So 10, 10, 7, 7 and 7. We just need to simplify this or calculate this thing on non-scientific calculators. So these 2 brackets are repeating 2 times, so raised to 2, these 3 times, so 3. Simplify this, you will get this. So after 5 years, that machine will worth for this much. This is the cost. 6,515 rupees and 29 paisa. Okay, so here we are. Regarding the average rate of depreciation, I have added all the rates, five, and there are total five rates of depreciation. So divided by 5, it comes 8 by 2%. So let's take one more question. A person invested 4 lakh in a business. His grew at the compound rate of 10%. Oh, this is his growth is at the compound rate 10% for the first 5 years, and then there was a decline at the compound rate of 10%. What shall be the amount at the end of 10 years? Is it same as the invested amount? So amount invested is 4 lakh rupees. Here is the timeline diagram. 4 lakhs in the beginning, then his growth for first 5 years is 10%, 10%. Then the remaining 5 is it faces depreciation by minus 10%. So what is the amount at the end of 10 years? So what I've done here, I have taken the depreciation and the compounding simultaneously. Means increase and decrease at the same time. So for first 5 year, I have positive 10%. So this bracket is for growth and this bracket is for downfall. So 4 lakhs, simplify this, you will get 3 lakh 80,396 rupees, which is less than 4 lakh. So here we have our second topic of Unit 1, nominal rate of interest. Let's see what do we mean by nominal rate of interest. The nominal interest rate is the percentage increase in money you pay to the lender for the use of the money you borrowed. For instance, imagine that you borrowed rupees 100 from a bank 1 year ago at 8% per annum interest rate. When you repay to the bank, you must repay the rupees 100 you borrowed plus 8 rupees as interest. So a total amount you pay is rupees 108. So this rate of interest is called nominal rate of interest. So in all the examples which we have seen previously, all the rates were nominal rate of interest. Let's read further here. 8% interest rate is called nominal rate of interest. Also, a nominal rate of interest is the total amount of money that is earned from a particular investment. This is very important. Before taking various expenses like management fees, inflation, taxes, legal fees, staff salaries, depreciation, and many more into the due consideration. So let's understand this with an example. Fixed deposits. Usually fixed deposits gives 6% to 9%. Here we have 8% per annum with lock-in period of maybe 5 years. Suppose you invested 1000 rupees in this FD scheme, giving you 8% per annum. This 8% is called nominal rate of interest. They will tell you that this 8% directly, but they won't tell you what charges they are going to charge you. So this 8% is not the final interest you are receiving. So after 1 year you will receive, so according to this 8%, what we see in advertisements, you must receive 1000 rupees plus 8% of 1000 rupees. So I've taken here an example for 1 year. Normally 8% or 7%, they pay this much interest on minimum lock-in period of 3 years. So deliberately I have taken 1 year. So you must get back 1000 rupees and the interest amount is 80 rupees. My point is, this 80 rupees, you won't get exactly 80 rupees. There has to be some amount to be deducted by the bank as their expense or the charges. So this much amount you are supposed to get back. But in reality, you will receive less than this much because of service tax. So these are roughly 10%, processing fees 2%, service tax, other charges, and many more. You should ask what are the hidden charges when I'm going to withdraw my fixed deposit. So that 8% which we see into the advertisements is a nominal rate of interest. Bank will deduct 2% of interest, so 1.1 rupees and 60 paisa. So it may happen that you may receive this much amount or less than this, because I have included only one charge which is deducted by the banks. So actually you have not received 8% interest rate. So 8% was nominal. What is the actual rate of interest you have received here? You got 78 rupees 40 paisa as a actual interest, where according to calculation you are supposed to receive 80 rupees as your interest amount. So what is your actual rate of interest? How to calculate that? So this is the amount you received as interest on the investment of rupees 1000. So just divide it and multiply it by 100. So this is the actual rate of interest. We have seen they were saying that 8% on fixed deposits, but the actual is this. This is also called real rate of interest after deduction of taxes, service charges, or the inflations. So this is nominal. So there is nothing more to tell on nominal rate of interest. What we have studied earlier, and that is the nominal rate of interest. Let's see effective rate of interest. This is interesting part. So let's understand this concept by an example. The notion of effective rate of interest comes in role when the interest is compounded half yearly, quarterly, or in some cases monthly. Suppose yeah, why? Because why in half yearly, quarterly, and monthly? If it is say annually, then it is equal to then the nominal and effective rate of interest, they are same. So I must have these condition: half yearly, quarterly, or monthly to explain effective rate of interest. Suppose you had deposited 1000 rupees in a bank giving 5% compounded half yearly. I have written 5%. I haven't written I haven't written per annum here. This will make a big difference in the explanation. So what I have written, just 5% compounded half yearly. So this diagram will explain the meaning of 5% compounded half yearly. So for the first half, that is 6 months, the rate of interest is 5%. Second half is again 5%. That is the meaning of 5% without PA, per annum. So on 1000 rupees I'm going to get 5% interest, that is 50 rupees. Total amount after first half is this much. Then I'm going to get again 5% on the this much amount, 1050 rupees. So this is the calculation. 5% of 1050 is 52 rupees, and this is the final amount. So after 1 year I will get this. Let's read further. 5% compounded half yearly in a year gives you 102 rupees 50 paisa as interest. We want one effective rate of interest which is equivalent to 2 times of 5% interest rate. So I don't want 5% and again 5%. Just give me one rate of interest which is equivalent to these two, and I'm going to get same interest money, this much. I want one. How to calculate one annual rate of interest which is effective for 2 times rate of interest? That's easy. Let's look at the calculations, how it is easy. You have deposited 1000 rupees. Final amount by taking 5% compounded half yearly, that is 2 times, is this much. Interest amount, so final amount minus initial, 102. So rate of interest is this much extra money on 1000 rupees into 100. That is the formula to find the rate of interest. So 10.25. If you look at the diagram for 1 year time span, this is my 6 months, 5% here, 5% here, 1000 rupees deposited here, and final I have received 1000, this much. So you there is chances that you may answer for effective rate of interest is 10%. Instead of taking 5%, you give me one effective rate of interest. Obviously you will tell 5% plus 5%, that is 10%. That's not true in case of compounding half yearly or quarterly. So the effective rate of interest is not 10%, it is something more, 10.25%. So this 10.25% is called effective or equivalent, is effective or equivalent to 5% plus 5% rate of interest. So the effective rate of interest is this, will give equal interest money equivalent to 5% plus 5%. You can see this. This is the calculation. You are going to receive the same interest amount. So let's do it again. 5% compounded quarterly. So this time I have 5%, I am compounding it quarterly. Remember, I haven't written here per annum. This is not here. So in a 1 year time span, I am receiving interest of 5% 4 times. So this says that 4 times 5% interest means after every 3 months. In blue color, I have written interest amount, interest money. And in red color, it is the final amount after taking the interest. So for first quarter, 5% of 1000 is 50 rupees. Add it into the 1000. This is the amount in the end of 3 months, first quarter. So 5% of this is this. This is my interest. Just add this to this amount, you will get this. My question is, this 1000 rupees grows to this much, 1215.50 paisa, just by taking 4 times 5% interest. Normally, usually I'm going to say this is equivalent to 20%. No, this is not equal to 20%. Then what is the effective rate of interest which gives me same interest money in the end of year? So total interest earned, this, how to convert it to percentage? So effective rate of interest is 21.5%, not 20%. So there's a difference. You cannot add the 5% in order to get effective rate of interest. That's different. In fact, that's wrong. So after this much explanation, let me put the formula in front of you to find effective rate of interest. This is the formula. Effective rate of interest is equal to 1 plus r upon n raised to n minus 1. Do not confuse yourself with this n by looking at by learning from the different teachers. So this r by n is very important thing. What is r? R is annual nominal rate of interest. Normally, if it is written 8% per annum, my r is 8 upon 100. What is n? N is number of compounding periods in a year. If they are talking about compounding half yearly, so n is 2. Quarterly, n is 4. Monthly, n is 12. Now there is a big confusion with this n in some examples. Let's see. For the previous examples, 5% compounded quarterly, I haven't written this p per annum here. So I'm going to treat this as just compounded quarterly, 5% for every quarter. So r percent is 5%. So what is r? R is 5 upon 100, so 0.05. N is 4. So effective rate of interest is, so I'm not going to write this n is equal to 4 here. I'm not going to write. I've written only 1 because 5% is for every quarter. It's not for whole year. If I have written per annum there, so I have to divide that rate by 4. Since that 5% is for every quarter, this is not going to divide by, I'm not going to divide it by 4. So it has to be 1 there. So this 1 is there. And this 4 is 4 times I'm going to receive the interest. In further examples, this n and this n is equal, because everywhere I will write r% per annum. So I have to divide that r by n in order to distribute the rate of interest. Okay, so just look at the calculation. 1 plus 0.05 and raised to power 4 comes this, minus 1, it is this. Just multiply it by 100 to convert it to percentages. So 21.5. It's same. So here we have one more question. What is the effective rate of interest corresponding to nominal rate of interest 7% per annum compounded quarterly? Take this in account. We have per annum. So that 7% is for complete 1 year. Okay. And they're talking about quarterly. So I have to divide this 1, 2, 3, and 4. 1, 2, 3, and 4. So I have to divide this 1 year timeline into 4 pieces. So which makes me to divide this rate of interest to 7 by 4, 7 by 4. In previous example, this was not there. Okay. So that's why I have taken 5%, 5%, 5% everywhere. So 7 by 4. So nominal rate of interest is 7% per annum. So what is R? R is this 0.07. Here we have compounded quarterly. So N is 4. So I need to divide R by 4. So let's look at the calculations. Do it. Power 4 is okay. The final thing is this multiplied by 100. So 7.18% is the, what is the answer? C is the correct option. Let's take one more question on effective rate of interest. The bank pays interest quarterly at 8.85% per annum. What is the effective rate of interest? Effective rate of interest, this is the formula. Let's identify the values. R% is given this. So what is R? R will be 8.85 divided by 100, which is this value. And interest is paid quarterly, so N is 4. I need to divide this rate of interest by 4 also, so I have done here. So divide it by 4, take its 4th power, you will get this. Okay, so I guess this is the last example on a bank gives 6.25% per annum interest monthly and recurring deposit. So interest is being depositing monthly. Okay, so what is R? R is 6.25 upon 100. 6.25 upon 100, which is 0.0625, and this is for per annum. So I need to divide it by 4. No, not 4, sorry, because it's been monthly. So divided by 12. So by 12. So here I have written by 12. Take its 12th power, you will get 6.4. So let me conclude this by saying this. So this is my 1 year timeline. 6.25% is for this complete year from here to here, but they are compounding monthly. They are giving in recurring deposit, we receive interest every month. So for 12 months, so suppose this is 12 months, so what is the rate for every month? 6.25 divided by 12. For this, 6.25 divided by 12. For this, for every month, the rate is 6.25 divided by 12%. That's why we have to divide it by 12. And the effective rate of interest is 6.43, which is a little bit more than the nominal rate of interest. This is nominal rate of interest. So in this video we have completed our second topic of unit 1. So let's stop here. Thank you.